In this video, we'll go over blockchain in greater detail. We will try to understand its essence, why it was created, how it works, and its potential. The primary goal of crypto was to create a digital currency that allowed peer-to-peer transactions without the involvement of a third party. If fiat currencies have their own financial system to effectively and securely share value, so do cryptocurrencies. While the former is made of banks, ATMs, banknote printing services and so on, the latter is built using blockchain technology. At a high level, a block is composed of a list of data, and the chain is a stack of the blocks of data, which continually grows over a specific period of time. In a Bitcoin blockchain, data in each block is comprised of financial transactions broadcast by users of the network, along with the cryptographic proofs that those transactions are valid. At a deeper level, a blockchain is a distributed ledger, similar to a database, but rather than being controlled by a central authority, the ledger is dispersed across multiple computers, called nodes. The nodes can be located all over the world and run by anyone with an internet connection. At its core, a blockchain is a ledger through which data is added and updated in real time via consensus of the different nodes running the software in the network. A simple analogy for understanding blockchain technology is a Google Doc. When we create a document and share it with a group of people, the document is distributed instead of being copied or transferred. This creates a decentralized distribution chain that gives everyone access to the document at the same time. No one is locked out, awaiting changes from another party, while all modifications to the doc are being recorded in real time, making changes completely transparent. When all of these features are combined, blockchain becomes extremely difficult, if not impossible, to alter or hack. That is why blockchain technology is so powerful. Consensus is one of the key components of blockchains that has allowed them to materialize. However, in order to understand consensus, we must first understand why Satoshi Nakamoto, the anonymous creator of Bitcoin, created a blockchain in the first place. Banks and clearinghouses are the ultimate arbiters of conventional, cash-based financial system. If person A sends $10 to person B, $10 is deducted from person A's bank account and credited to person B's. However, the actual settlement of the transaction or clearing process can take several days on the back end. Clearinghouses and a network of other financial institutions verify the transaction's authenticity and that person A has the necessary funds to send to person B. Prior to the invention of Bitcoin, the primary issue with digital currency was how to avoid a central clearinghouse. There was no way to validate that if person A sent $10 to person B, she couldn't just turn around and spend that same $10 again. This was known as the double spend problem. In a cash-based system, person A cannot spend the same $10 that person B was given in cash. But the process is more complicated in the digital world without the use of a central clearinghouse. This is where blockchains come into picture. Bitcoin blockchain is a peer-to-peer network, which means it has no central authority. Instead, all peers in the network are equal and serve as verifiers of the ledger's state. However, in traditional financial systems, central clearinghouses determine the state of ledgers. Satoshi Nakamoto recognized that converging on the accurate state of a blockchain ledger in a P2P network required an innovative method called as consensus that did not sacrifice the network's decentralized nature. Remember that in Bitcoin, a new block is created and added to the chain every 10 minutes. Those blocks are validated and appended to the blockchain by the network's distributed nodes. There is no clearinghouse. There are numerous network operators who run nodes and automatically validate the network's blocks and transactions using a set of consensus rules that can be run by anyone with a computer. They carry out this function using Nakamoto consensus, which is a version of the distributed computing concept known as proof of work or Byzantine fault tolerance. A blockchain, like a central clearinghouse, can achieve secure and accurate consensus on the state of the ledger through a series of game theory incentives, cryptography, but over a decentralized network of nodes where no single entity has control. The use of cryptography in blockchains makes data verification simple and nearly impossible to forge. The concept of blockchains has grown even more since Bitcoin. Rather than using a blockchain solely for financial data, new projects seek to use it as a medium for storing and validating arbitrary data, such as social media applications or gaming data. This is the underlying concept of platforms such as Ethereum, which uses a virtual machine layered over the blockchain as its core settlement layer. Overall, blockchains are a new protocol architecture that eliminates the need to trust individuals in an open network and providing a medium of value transfer that is free of the control of malicious parties. Storage and backup are redundant in a blockchain network, which means that as long as numerous people run nodes, there is no single point of failure. Because of this breakthrough technology, blockchains have received a lot of attention and hype for a variety of uses, some of which are promising and many of which are, at best, speculative.